Okay, today we work on solving equations. Third hour did not get class because they were signing up for CIS courses. So we're not pushing the test back a day. You guys will be on schedule as normal. They get kind of everything crammed into one lesson tomorrow. That's the way it is. It's the way it goes. Sorry for third hour. Solve the following equations. You guys remember how to solve equations, right? Okay, this should be full review. What do I do first? Distribute what? Negative 5. So I have a negative 5x plus 5 equals 3x plus 2. What is my next step? Combine like terms. So 2x and negative 5x make negative 3x. Now what?
Oh, 2x minus 5x.
So now I'm going to subtract 3x from both sides. So negative 6x plus 5 is equal to 2. Sure, you can create a positive x or a negative x. Doesn't matter either way. I subtract the 5. I get negative 6x is equal to negative 3. Some teachers tell you always make a positive x. Some teachers tell you always put the variables on the left-hand side. I say you're in college algebra and you can do both, right? We divide both sides by negative 6 and we get?
Just kidding. If you add it instead, why did it not work? You did the same thing. What did I do? I got 2.
So negative 6x is equal to negative 3. I divide by negative 6. So negative 3 over negative 6 is going to be 1/2. Okay, if we have a fraction, we say no big deal. Letter B, what do we do to both sides? Add 6, and I get 3 over 2x is equal to 27. Multiply by the reciprocal to get rid of the fraction. Times 2 over 3. Notice how the x's can't, or the 2/3 and the 3/2 cancel. When you take 2/3 times 27, notice you multiply by the numerator, you divide by the denominator. 27 divided by 3 is 6. I'm sorry, 9 times 2 is 18. Very good.
Wait, okay, how did you get that?
27
Right?
divided by 3 is 9. Times 2 is 18.
Well, if you think about it, it's 9 times 3, so 2 of those is 9 times 2, which is 8.
You divide by the denominator, multiply by the numerator.
Divide by the denominator.
Yep. All right, let's look at letter C. Here we have fractions. Everybody agree that they don't like fractions? So we're going to get rid of fractions, okay? All right. So suppose, anybody want to guess my weight? 120. Wow. 187, 175. I'm probably right. You're probably close to 187. Probably right about that 187 spot. So suppose we had a large, we'll say, dumbbell that weighed 187 pounds. Okay, and I put it on the other side of a teeter-totter. Okay, and I was on the other side. We would balance out, correct? Everybody good with that? Suppose I put 18 of me on one side and 18 of the other on the other side. Would we still balance out? Because you can multiply both sides by the same number and maintain balance. So in order to get rid of fractions here, I'm going to multiply both sides by a number. Does anybody know what number I'm going to multiply through by? I'm going to multiply by 15. So just to be clear, folks, there's not just one choice for a number you can multiply through by. You can multiply through by any number that exists. Because you can multiply both sides by the same number and maintain equality. I choose to multiply by a number that where 3 and 5 divide into evenly. So 15 would work. 60 would work. Okay? So let's see what happens here. As I multiply through by 15, Sid, this was your question. Remember, divide by the denominator, multiply by the numerator. 15 divided by 3 is?
5.
Times 4 is? So you have 20g plus?
Plus 12 equals.
No. 15 times 12.
Wait, why are you doing 15 times 12? Okay, never mind, because you're distributing. Okay,
Yep. So 15 times 12. 180. Now 15 times 2/5. So 15 divided by 5 is?
3
Times 2 is? Good. So I no longer have any fractions. Is that good? You like that? You like getting rid of the fractions? So now this is easy to solve. We can subtract 20g from both sides. And we get 180 is equal to negative 14g. Oh. Why do we have to hate on the fractions? So I'm going to say negative 90 over 7. So you tell me what number to multiply through by for D in order to get rid of the fractions.
15.
So the question, what? Hold on. Shh. You see it? Okay. 30 works. Should we multiply through by 30?
Oh, it's a big number, but it'll work.
Okay. So what is 30 divided by 5? 6. So that means I distribute 6 through the top. Okay, so I divide by the bottom, I multiply by the top. So I multiply top by 6, I get?
18x plus 12.
Good. Minus 30 divided by 3 times 1.
Negative 10.
30 divided by 2 times 5.
Good question.
75x.
Plus 10?
And then we got plus 10. So now I've gotten rid of the fractions. Olivia likes that. She says, yes, that's great. That's what I've been wanting to know that my whole life. 18x plus 2 is equal to 75x plus 10. I'm going to subtract the 75x from both sides. 18 minus 75, negative 57x, plus 2 is 10. Subtract the 2, negative 57x is equal to 8. So x is negative 8 over 57. So there was a time in algebra where you were maybe able to look at the problem and see the answer right away, and you asked your teacher, well, why do I have to show my work? Can we all agree that you can't tell that the answer is negative 8 over 57 by looking at the problem? So therefore, you show your work, and we get to where we need to be. Please flip it over. So we have one of the most wonderful things in mathematics that you will unfortunately abuse. I apologize for that, but I'm just predicting what's going to happen down the road. Zero product property says if A times B is equal to 0, then what? B times A is 0, good. One of them has to be 0. The zero product property is great, and it doesn't work for any other number. You will try to make it work for other numbers, and I'll show you how you do that later on. You really shouldn't, but you do, unfortunately. When we start to leave the realm of linear equations, so linear equations mean equations to the first degree. We just did equations to the first degree, right? And that was like all the mathematics that you were learning up through like 8th grade. Then all of a sudden you started learning about this factoring technique and everything, right? Factoring means to write as multiplication. Multiplication. And in order to solve things that are not first degree, we like to factor and set them equal to 0. So look at the first example here. X squared minus 2x minus 15 is equal to 0. This does factor. And once we have it factored, x minus 5, x plus 3 is equal to 0. So please notice that this is A times B is equal to 0. That fits the form that we had. So I set both of these equal to 0. X minus 5 is equal to 0, and x plus 3 is equal to 0. And so you've learned, as you said, that x is equal to both 5 and negative 3. Any questions there? Good. So let me show you the math that you do. You see this, you're like, oh, factor. X times 6x minus 1 is equal to 5. So we're going to go x is equal to 5. And then we're going to go, let's see, we'll add the 1 and we'll get x equal to 1 out of that. Can everybody see how people do that sometimes? Now, what you just made up a new rule which does not work. It has no logic, but you know, it kind of looked cool for a while. Notice, folks, it is the 0 product property. We do not have a 5 product property. Okay? Suppose that I know this to be true. Just to make my point one last second here. A times B is equal to 12. Can you say anything about A or B?
Nope.
Well, how about this? One of them has to be positive, right? No. I mean, they both could be negative, right? One of them has to be 3. No, you can't say anything about A or B in that situation. There's no 12 product property. There's no 5 product property. There is a 0 product property. 6x squared minus x minus 5 is equal to 0. Now I am allowed to go to work. Does that factor? Very good. 6x plus 5 and x minus 1.
Oh, yeah.
Notice that if you check the inside and the outside, you do get negative x in the middle. So 6x plus 5 is equal to 0. So x is going to be equal to what? Negative 5 over 6. And x minus 1 equals 0. We have x equal to? Great. Notice how many solutions did you have? 2. What was the degree of the equation? Oh, is that great? Notice how many solutions you had on the previous page. 1 for each problem. And the degree each time was 1. What's the degree of the problem for letter C? How many solutions do you think you're going to have? How do you want to start? Good. So I factored out the x. What now? Excellent. Mr. Jack? I have a plus 1. I have a minus 1. So x is equal to 0, 1/2, negative 1/2. See how this x is out here? Suppose that instead of an x, suppose it was a 4. Does that change my answer? Yeah, the 0 is gone, isn't it? You see there's 1, 2 x's, so you have 2 solutions. When you add the x out here, now there's 3x, that builds in the third solution. So a constant does not produce a solution. You try letter D on your own, see where you get. Go. I worked slowly behind you. As you finish up, you can glance up and check to see where you were at. We will now complete the square. Completing a square, how does that work, and what is a perfect square? I'll show you. This is a perfect square. Everybody agreed? This is also a perfect square. Why is this a perfect square? Why is this a perfect square? Good. So when two binomials multiply to make this trinomial and they are the same, it's called a perfect square. Now here's the interesting piece. I'll show another one to you. X squared plus, we'll go 6x plus 9. That's a perfect square because it's x plus 3 times x plus 3. What do you notice about the number in the middle? It's double the other two, right? It's double the other two. So, for example, if I had x squared and I had 49, can somebody tell me what would go in the middle here? 14. It's the square root of that doubled. So, hold on. So, suppose you had, I'll do one more, x squared plus 18x plus, what number goes on the end? Half of that squared. 81. Yep. So you can see that 9 is the special number you're looking at, right? This one's double 9. That one's 9 squared. 5 is the special number you're looking at. 5 squared is 25. Double 5 is 10. 3 is the special number you're looking at. Squared is 9. Doubled is 6. So that's kind of the process of what we see for completing the square. Let's now get to work. Here's one way of completing the square. There are many ways of doing it. I'm going to move the 5 over to the other side. Completing the square is not a process of factoring because this does not factor. So we are not going to use the zero product property. Can somebody tell me what number would I add to complete the square? How did you get that? 2 divided by 2 is 1, squared is 1. Take the middle number, divide it by 2, and square it. So if you need that written out, take the middle number b, divide it by 2, and square it. That's what you do to come up with that number. In order to maintain balance, if I added 1 to the right or left, then I add 1 to the right. Excellent. So now this factors, doesn't it? What does it factor to? Equals 6. I now have a perfect square equal to 6. How many solutions should I have? 2, because it's x squared. How do I get rid of squaring something? Take the square root of both sides. What's the square root of x minus 1 squared? And when you take the square root of a variable squared, list the positive and the negative. So plus or minus the root of 6. Now what do we do to both sides? Add 1. So x is equal to 1 plus or minus the root of 6. Should have had this with Miss Kruger. Should have had this with Miss Hansen. Definitely not voodoo math. That's a great question. I could give you an answer to that. Last one, 2x squared plus 2x minus 1 is equal to 0. Can't have a number in front, divide through by 2. The reason why that works so well is what is 0 divided by 2? So notice we get x squared, we have plus x, minus 1/2 is equal to 0. What should I do now? Move the 1/2. Excellent work. X squared plus x equals 1/2. I now complete the square. This one's not as easy to see. We take the middle number b, which is 1. We divide it by 2 to get 1/2. We square 1/2. What's 1/2 times 1/2? 1/4. What does the left side factor to? Good. What's a half plus a fourth?
3/4.
The square is now completed. I'm going to have two solutions. What do you do to get rid of the square? I'm left with x plus a half is equal to, can you take the square of the top? Nope. So plus or minus the root of 3, can you take the square of the bottom? Yep, what do you get? 2. Now I want to move the half over. So I subtract a half. X is negative 1/2 plus or minus the root of 3 over 2. Which part? What's the square root of 3? Square root of 3. What's the square root of 4? 2. So the square root of 100 over 9 is 10/3. You take square root of the top, square root of the bottom. This is equal to the square root of 100 over the square root of 9. That's a fact. Okay, good job. Way to go.